Welcome back, chemistry fans. Today, we are going to deal with Unit 1, Topic 4, and we are going to be talking about the metric system. So let's jump right into it here. Share with you my screen. Talk about how you can get into this Unit 1, Topic 4. And so if you notice, this is your Unit 1 note packet that you can find in the module section of your Canvas pages, and you would just simply scroll down past 1, 2, 3 till we get to the metric system. So this is something that everyone should be very familiar with. It shouldn't be too difficult for us to get through this rather seamlessly. Let's jump in. So with this metric system, what we need to know is that there is an easy way and a more challenging, more methodical way for us to deal with conversions, all of which starts with our understanding of the prefixes that are associated with the basic units. So you may have in the past had some mnemonic devices out there, King Henry Dance Monday drinking chocolate milk, and that would help you get some of the basic units. Well, in chemistry, AP chemistry, we're going to go beyond that, and we're going to have some units that are a little bit more difficult, larger, smaller. So we need to be familiar with the very, very small size of atoms and the very, very big distances that could be measured in between them. Okay, so let's jump into this right here. I'm going to try and get us to understand what these units are. So in this first unit here, what we have that sticks out to us, or that I need to call your attention to, are these base units. They sit right here in the middle at 0, and that's what the BU stands for. And the base units that we need to deal with in the metric system are meters, grams, and liters. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, they're all going to be right there on this middle line of the number line. And it's only if we jump by a power of 10 that we need to convert these into different units. And so again, the King Henry danced Monday drinking chocolate milk that you may be familiar with. It may have been died while drinking chocolate milk. Any of these mnemonic devices would work for you. What this gets you to are the base units. So we have kilo, whoops, try that again. Kilo, hecto, deca, hecto, it's hecto, kilo, deca, meter, this is the base unit, and then we have deci, oh my gosh, I did have that right, deca, and this is deci, and this is centi, and this is milli. So kilo, hecto, hecta, hectometer, I think that's a hectometer. Decameter, deci, centi, milli. All right, well, once you get to that, no, it's a hecta. It's a hecta, so kilo is the only odd one that sticks out there. Once we get to those units, you can use the number line, and we'll try and explain that here to you in just a second. But what I want you to notice is that each one of those units is its own separate line. So for the first 6 units, they all are just one line apart from one another. But then there are no names for the 7th, 8th. It's not until we then jump out to the 9th line that we get to mega, is the capital M, which is distinguished from the lowercase m for milli. And then we would have a giga, and we would have a tera. And those are the big units out to the left of this number line. If we go down to the small side, again, the first 3, deci, centi, milli, all make one line's difference from one another. But then we get to this weird, awkward U, or upside down H, and that is a micrometer, or a micro whatever unit, gram, or a micro liter. And then we would have nano as the 9th line out there, and then it gets to pico. So those are the small units going out. And those are the new ones that we have not yet probably discussed in your science career in high school or in middle school. Now, how you use this number line, again, you've done it before, is if you have, let's say, 50 megagrams right out here on this portion of the line, and we want to find out how many milligrams that is equal to. You don't have to do any dimensional analysis. You don't have to do much math. All you're going to have to do is count the number of lines, and it will tell you the number of decimal points. So we will count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would mean the 50 will move its decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9. All these empty humps are going to be filled in with zeros. The decimal point would go to the end. You would then put commas in every 3, so that makes it easier for you to see. These are your hundreds, these are your thousands, these are your millions. This is 50 billion. So there are 50 billion milligrams in 50 megagrams. Now, if you go the other way, it works the exact same. If I have, let's say, let's do nano. So if I'm out here at nanometers, and I want to go all the way to a gigameter. Well, I could count lines. It's going to be easier for me just to know some skips. So here's 3, 6, 9, 12, 15, 18. So I have point. Oh, I didn't even say how many I had. Let's say I have 1,000 nanometers. And I have to then go 18 lines backwards. Oh my gosh. I'm going to run out of room. So I'm going to start it out here with my decimal point. Here's 3. Here's 6. Here is 9, 12, 15, 18. Well, holy Moses, this is a lot of numbers for me to try and get to count. And it doesn't mean anything to me. So instead, it's going to be easier for me to convert this into a scientific notation. So how many decimal points do I have to go to get it back to this point? Not to this point, because that point was where it originally was. I always put the decimal point in between the first counting number and the second value. The second value may not be a counting number. In this case, it's not. So how many places did I have to go? Here's 3, 6, 9, 12, 15. And that makes sense. I moved it 18 lines, but I already started with 3 over here. So if I subtract those 3, I'm back to 18. So I have 1 times 10 to the negative 15 gigameters, whatever that means. All right, so this is how we're going to utilize our scientific notation, our metric system all together. Not a whole lot to do with significant figures yet, but whenever we get to it, we'll make note of it. Now, some of you may be saying, well, that doesn't work for me. I need to be able to utilize something that is a little bit more concrete. It's a more mathematical approach to it. And this is where we can do dimensional analysis. So let me show you that exact same problem where we had 1,000 nanometers. Whoops, it's not on there. 1,000 nanometers that I then want to convert into gigameters. So in dimensional analysis, we write out our problem. Just did that. Write out all my conversions. I know that there are, for every 1 meter, there is 1 times 10 to the 9th nanometers. I believe that's correct. Let me go back to my number line just to make certain. 6, 9. Yep. And then for my gigs, I know that they are also an equal 9. So I know my second one is for every 1 times 10 to the 9th meters, there is 1 gigameter. All right. So now I'm going to start with my given amount, 1,000 nanometers. And I'm going to use these conversions right here. And I'm going to put in the matching value below. And that way, my units are going to cancel. I will cancel out nanometers with nanometers. I will then now, for every 1 times 10 to the 9th meters, there is 1 gigameter. And then I'm going to multiply all of my values across the top. So that means I've got 1,000 nanometers times meters times gigameters divided by 1 times 10 to the 18th nanometers times meters. Well, now what I should notice here is that my nanometers are going to cancel out, my meters are going to cancel out, and I'm left with the unit that I desire, which is gigameters. And if I put this into my calculator, 1,000 divided by 1 times 10 to the negative 18, what I get is 1 times 10 to the negative 15 gigameters, which is the exact same answer that I got using the number line. So whether or not you use dimensional analysis or use the number line doesn't matter to me. What you're going to have to be able to do is a conversion that is not using the number line. So many a times, our dimensional analysis is going to be set up with units that you are unfamiliar with. In chemistry, they do this and they love this. So we need to be able to convert, in this example, 140 centimeters into feet. I have my 2 conversions set up for me. 1 inch is equal to 2.54 centimeters. 1 foot is equal to 12 inches. They must give you the conversions, or they must be understood that these are things that you know. Both of these are supposed to be conversions that you are familiar with heading into the AP chemistry test. And if you're saying, I don't know these, start learning them. So I'm going to start with what I'm given. It is 140 centimeters. For every 2.54 centimeters, there is 1 inch. For every 12 inches, there is 1 foot. So I will multiply the values across the top, 140 centimeters, inches, feet. I'm not sure why it just did that. Feet divided by 2.54 times 12 is 30.48, 30.48 centimeter inch. Well, notice in this, my centimeters canceled, my inches canceled, and I'm left with my answer, which is what I wanted in feet. So now I've got 140 divided by 30.48. And what I get up is this big long answer, 4.5931759. How many significant figures am I allowed to use? This only has 2 significant figures. There is not a decimal. This has 1 significant figure, but it's an exact value. So it could be an infinite number of values. So it could be 1.0000 because it's an exact value. This could also be 1.0000 forever because it's an exact value. The same for this one, 12.00. So we don't include any of our conversions in significant figures. The only value that we are going to calculate with is the first one, 2 significant figures. So my answer will only have 2 significant figures, meaning my final answer is 4.6 feet. Let's do the same thing with these example practice problems. In this one, I'm dealing with a rate. The rate, I need to convert it into meters per second. It's right now in miles per hour. This is, you're traveling down the road, 35.8 miles per hour. I want you to convert that into meters per second. Okay. So what we need to know is how many miles or how many meters are in a mile. I don't know that. But what I do know is that there are 2,000. How many? Well, let's ask someone because I honestly don't remember. So let's do it. 2,400, 2,580, I think. How many feet in a mile? Let's find out. Go Google it. Feet in a mile. 5,280. I was so close, and I just screwed that one up. But let's figure it out now. Let's put it back in. 5,280. So there are 5,280 feet in 1 mile. There are 12 inches in 1 foot, and there are 2.54 centimeters in 1 inch. There are 3,600, well, let's just do what we know. There are 60 seconds in a minute, and there are 60 minutes in an hour. Okay. Now, let's do the conversions. I am given 3 significant figures. That's how many will be in my answer. This is miles. Whoops, let's do this. I'm going to make room for this. 35.8 miles per hour. Now what I'm going to do is I'm going to convert this. So I've got 1 mile is equal to 5,280 feet. For every 1 foot, there are 12 inches. For every 1 inch, there are 2.54 centimeters. I'd use the number line, and there are 100 centimeters per meter for 1 meter. So now I got what I wanted in. Now let's do the inches. So the bottom one was hours. So for every 1 hour, there are 60 minutes. And for every 1 minute, there are 60 seconds. Multiply everything across the top. 3.58 times 5,280 times 12 times 2.54 gives me a huge number, 5,761.45.152. All those units across there, I know it's all going to end up being in meters per second, so I'm not going to write those down. And then down on the bottom, I've got 1 times 1 times 1 times 100 times 60 times 60, and I end up with 360,000. All right, let's take those two values, 576,145.152 divided by 360,000. And what I end up with is 1.6004. I'm only going to use 3 significant figures. Right there is my answer. 1.6 meters per second. You're like, that's kind of small for going 35 miles an hour. But if you think about it, I'm about 1.5 meters. So in 1 second, this object is going past my height. That's pretty fast. Okay, this is everything that I wish to show with you. We're going to practice some more problems together later. Thank you so much for staying with me in this new topic dealing with the metric system. I will talk with you again very shortly. Thank you. Goodbye.